Okay, I already modeled here a stick model in the stud plane. This represents the whole length of our purlins. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 spans, and then these both ends here are the overhangs. So that means our support condition would start from the second node right here up to the second to the last node. Okay, that's what we're going to do right now. We're going to assign support conditions. So we'll create a pin and then assign that here. Okay, so this is the analytical model of our purlins. So it is simply supported at the top of the top chord of each chassis. So next we're going to assign properties. So the property we're going to use is from the section database. We will use the channel section. Okay, so from the American section we will use this channel, and we will use the lightest. I will try to use this 4-inch deep C4x4. Okay, let's use that. Click add, click close, and then assign to view. So if we look at the 3D rendered view, so this is now our purlins, but that is a trial section. We will see later on if this would pass the design. Okay, so next we're going to go to the load and definition. Okay, so for the load cases details, we would only have dead load, the live load, and the wind load, right? And there are two types of wind loads. So as what we have discussed earlier on our previous videos, we have loading for the positive, the downward pressure. We have also the wind load in the negative pressure. Okay, or the upward pressure. Now this is the upward pressure, the negative is the upward pressure, and then the positive is the downward pressure wind loads. So for the dead load, we have of course the self weight with factor -1. So the negative is the negative sign indicates the direction of the load. So if it is negative, that means going down. So aside from that, we also have the loading. The purlin is carrying a load from the roof, the corrugated roof framing. So going back here, the corrugated roofing sheets is given a 0.1 kilonewton per square meter. So 0.1 kilonewton per square meter will just multiply that with the spacing of the purlins, which is 0.886. So that would give us 0.886. 0.886. So this is now the value, linear load value, okay? The linear load value for dead load for corrugated roofing sheets. Member load. So we got that. So just assign this to view, and also this one. Next, for the live load, our live load is given as 0.60 kilonewton square meter. So once again, we're going to multiply that with our spacing of purlins, which is 0.886. So that would give us 0.513. So also member load. I'm going to add that. So why 6 going to sign. So next, for the wind load, so remember this wind load calculation we got here. So this one is for the positive pressure, 0.97, and then this one is for the negative pressure. So for the positive pressure, we will input under WL plus, okay? Once again, member load 0.97, so that is negative 0.97, and then assign to view, and then the another wind load. Now we got different magnitude right here, negative 1.64, and then the other one is negative 2.69. So for the zone 1, which is the inner part, so we will use 1.64. And then, by the way, we also calculated the width of the A. The A is the width of the zone 3 as well as the zone 2. So what governs is 1.7. So that would mean here in our model, so the overhang itself would take a greater magnitude of wind load upward direction. Okay, so first we will input these values right here, add that. So member load 1.64, and then the other one is 2.69. 2.69. Now this 1.64 will add this load in the interior zone, zone 1. So assign to select beams, assign, and then this 2.69 we will add that in the zone 2. Assign to select the beams, assign. So we've already done inputting all the load cases. Now we will proceed with the loading combinations. So what are the loading combinations we're going to use? We have that right here, combo. So we're going to use these loading combinations right here, but for simplicity we'll just take this tool3-2 as well as tool3-3, tool3-3 as well as this one. Okay, auto load combination, no define load combination, the 1.2 dead load plus 1.0 live load so 0.5 live load and then 1.0 wing load direction, wing load positive direction. So dead load, live load, and wing load. So this 1.2, this one is 0.5. Dead load plus 1.0 wind load positive Okay. We will also include the loading combination for the deflection check later on. So dead load plus live load. So, okay, we will now proceed with the perform analysis, add, and then the design. So this is still design, so we're gonna use AISC for our design code, and then the method is LRFD, and then no other design parameters we're going to use in for the yield strength of steel. We're going to use the grade 40 A36 steel. So add and then assign to view, and then we're going to assign check code as well as steel takeoff. So we're gonna run this one. 7. So let's check for failing members. Failed members, there are 2. That means we might want to change our steel properties. Maybe that one. And let's run analysis again. So done. Specifications, failed beams. So there are no failed beams. And if you're gonna check our deflections, okay, that's it.